Sure. So my name is Brian O'Connor. I'm the Technical Director of the Analysis Core at the UCSC Genomics Institute. I work on the Dockstore project with the GA4GH and OICR, and also on the Toil project at Santa Cruz. And together what we're trying to do is, between those two projects and other projects that we have going on in the group, we're trying to build infrastructure that lets us process sequence data at scale. So that's really the sort of central theme running through these slides. So today I'm going to tell you about Toil and Dockstore. So Toil is a cloud-based workflow and tool execution system, and Dockstore is a mechanism of sharing tools and workflows. So I'm going to dive into the details of those projects and tell you a tale of two projects, essentially. So on the Dockstore side, it's really all about how we package up tools. And I'll tell you a little bit about the background of this project, why we created it, and how it led to the GA4GH tool registry API standard that we're promoting right now. And ultimately what we see happening here is Dockstore leading to a sort of federated network of repositories that all speak the same language. So tools and workflows that are shared in one repository can be used in another or pulled from another. So on the Toil side, it's really all about running workflows and workflows that are constructed from individual tools from a source like Dockstore, to how to define those workflows in Python and execute them. It also recently has had added support for CWL, which is an emerging workflow definition standard. And really the whole goal for Toil is executing these workflows, whether they're Python or CWL, at scale, leveraging cloud environments. And what I particularly like about Toil is it's really quite robust against failure and efficient. And I think those are two unique qualities in addition to working on cloud environments. Okay, so to give you some background on Dockstore and why this project was created, some of you may have heard about this project. I recently gave a very similar talk at the GA4GH meeting that just wrapped up in Vancouver. So some of you may have heard the background story on Dockstore and how it was created. But for those of you that didn't, Dockstore really came out of the pan-cancer analysis of whole genomes project. And this was organized at OICR. And really it was a distributed project with hundreds and hundreds of researchers looking at about 2,800 cancer donors, which corresponded to about 5,800 whole human genomes. That data set was actually spread all around the world in 8 different sites. And the goal was to take that data and consistently analyze it with a common set of pipelines. And to do that, we had 14 cloud and HPC environments located all around the world to actually do that data processing. At our peak, we were running and managing about 630 VMs, and that corresponded to 15 to 16,000 cores simultaneously being accessed in this project across all these environments. So it was a highly distributed project, and we really needed a mechanism to package up our tools, our workflows, and make them portable. It took several iterations of our infrastructure to get to the point, and also took the maturity of Dockstore becoming a 1.0 or Docker becoming a 1.0 release, and having that core technology of Docker become stable and ready for production use. It took that to get to the point where we could actually send tools out, send workflows out to various environments, and have them work. And so what we ended up with is a sort of containerization approach that was built on Docker. And with that sort of container approach, you can take that and add a workflow definition or config files or some reference files. We even did Docker within Docker, which is a pretty interesting and kind of quirky way to do things. But this containerization approach using Docker really was the thing that ultimately allowed us to have a very sort of seamless portability between these 14 different sites. Before that, we were using essentially cloud-specific APIs in each of the sites to build up infrastructure from scratch. So for the Peacock project, this is a huge step forward, and essentially using Docker was a revelation for us that you really could package up our core analytical workflows, BWA mem alignments, Bro, DKIPZ, Emble, and Singer, best practice variant calling pipelines, and you could move them from cloud to cloud, HPC to HPC environment, and get the same results. So what we decided to do as PCOG's core analysis pipelines finished running, we realized that the sort of approach we were taking here was actually quite powerful. And as the Cancer Genome Collaboratory at OICR started to move forward as a project, one of the things that we wanted to develop for that is a formalization of the way that we used Docker. And so that's really how Dockstore was born. What Dockstore is all about is it's trying to solve two core problems. One, how to package tools. So this, what I was talking about with Peacock, how you actually move tools from cloud to cloud or VM to VM or server to server, and yet be guaranteed that they're going to produce the same result, that they're going to generally speaking, work the same and just work. And the other side that we thought was missing, so that first side was really, solved by Docker, and there's good industry support out there for an ecosystem of things inside Docker containers. What was missing, though, and we felt that we needed to formalize as part of the work that came out of PCOG, the work going into the Cancer Collaboratory, was linking those Docker-based tools with something that describes how to execute them. If any of you have gone to Docker Hub or Quay.io or these other sites that serve up Docker containers, you'll notice that the basic way that it tells you how to run the tools inside those Docker containers is a human-readable README. There's really not a sort of standardized, structured way of saying this is the tool inside this container, and this is how you run it, these are the inputs, these are the outputs. So what we decided to do is link Docker images with descriptors and use one of two standards for that descriptor, the Common Workflow Language, which is an independent project that's been used heavily by the GA4GH, and the Workflow Description Language, which is used and supported by the Broad Institute in their FireCloud environment. And so essentially what that provides is it provides both a human and computer readable definition of what's inside that Docker container and how to execute it. So that's really the core of what Dockstore is doing. In terms of the architecture for this platform, first of all, it's built on top of public tools. It's a public website. This is something that we are encouraging people in the community to use. You can go onto Dockstore today and use it and register new tools, register new workflows, or find tools or workflows that are in our catalog and use them. But what we want to do here is we didn't want to reinvent the wheel. There are some really good services out there. We just felt it was missing this sort of connection between the definition of the tool and the Docker container. But we want to stand on the shoulders of giants here. So we built on the best practice, the best architecture we could find, and for open source development, for sharing Docker containers, that's GitHub or Bitbucket for sharing the Docker file, which defines how to build the Docker image, and that descriptor, which describes how to call the thing inside that Docker image. So we use those sites, GitHub or Bitbucket, and then on the Docker building side, we use Quay.io or Docker Hub. And those are responsible for building the Docker images and also hosting them. And so this is nice for us because both, GitHub or Quay or Docker Hub or Bitbucket, these are very high capacity sites. So we can support, thousands and thousands of containers and projects and images without really having to scale dramatically on the Dockstore side, which is an academic project. So Dockstore.org, what it essentially is doing is it's a registry for these Docker images, linking them to this descriptor and providing that both through an API but also through a graphical user interface. And as far as the API goes, I'm going to talk about it more later on in the talk, but the initial version of our API was used as sort of the basis for establishing a tool registry API with the GA4GH. Okay, so Dockstore, as of a couple weeks ago, we actually hit our release 1.0 milestone. So we feel that the site is ready for other people to use. It has a great set of core features. One of those new features is the GA4GH tool registry API. We are now supporting the 1.0 version of that. So that's great that Dockstore and the GA4GH tool registry API have hit that milestone essentially at the same time. We're also supporting displaying and sharing and launching CWL-based tools and WDL-based tools. And in addition, CWL also had a 1.0 release. So we're up to speed with the 1.0 release of CWL. So in many ways, our 1.0 release happened at the right time, where we had a release of the generic API and a release of the CWL tool descriptor language all at the same time. We also have preliminary support for CWL and WDL workflows, which string together the tools that are registered on Dockstore. And you can see a full list of all the updates. It's been under active development, so there have been a lot of additions. You can see the updates here. The other point that I want to make is we're adding content, and as the PCOG project is in its final sort of phase of analysis and publication, we're making sure that the PCOG pipelines that we used are registered on Dockstore and made available to the community. And there's a working group right now that's testing those PCOG workflows that are registered on the site to validate them and essentially sign off on them for the sort of legacy of the PCOG project. Okay, so I just wanted to give you now sort of a brief tour. For those of you that haven't seen Dockstore, it's a nice, fast rendering website. On the main page, you can see it shows the top sort of available containers. These are the most recently registered containers. And it also shows, background information about the project, links to documentation, that sort of thing. If you go ahead and search, you can actually go ahead and search, and that search is happening in real time. So as you type, we're searching the name of the container, description, and that sort of thing. And here I'm just showing the search results for pulling back our PCOG workflows. You can see we have the BWA MEM, DKFZ, Sanger, and Delhi workflows. So those are the core workflows we have from the project, along with some other utilities that the project has created. And I would expect this to be fleshed out. We're waiting for the final release of the Broad workflow to be considered complete for the core pipelines of this project. And we're also anticipating that our consensus calling approach will be registered in the not too distant future as well. Okay, so if I click on one of those, again, Dockstore is really this graphical interface that brings together the Docker image with the descriptor of how to call the tools inside of it. That's the core functionality. But we've brought together a lot of information. So I clicked on the Sanger workflow in this case, and you can see a lot of the details about it, including who was the author, links to GitHub and Quay, so it's linking the source code with the built image. And also on the right-hand side, you see information about pulling the Docker container and convenience methods for things like sharing over email or creating a note in Evernote, that sort of thing. And then at the bottom, you actually see it's a little bit cut off here, but we support Discuss, so that way people can actually have a conversation about this particular tool within the page itself. Now, we provide links back to GitHub or Bitbucket, which most projects will want to have issues open there and that sort of thing to track their project. But in this case, you can actually have a thread of conversation happening within the page, which I think is a nice feature. The other thing I want to show is at the very center you have this launch with capability. And right now we have a Dockstore command line, and what that's designed to do is if you find something that you like and want to try out on Dockstore, the Dockstore command line is wrapping a few commands behind the scenes to make it easier to run this tool on your workstation or on your virtual machine or on your HPC node. And it's basically a two-step process where you're getting back the Dockstore JSON, which defines what the inputs and outputs are, that you can then edit for your input paths and the output paths that you want things written back to, including S3 locations or inputs from HTTP. And then the Dockstore command line also gives you the ability to take that and launch that. Now this won't be something that you'll want to necessarily do if you're going to run 1,000 instances of this Docker container and process a ton of data, but this is certainly making it very accessible for trying out a tool in a very standardized way. So all tools registered in Dockstore follow a very similar pattern to what you see here, and workflows follow a similar pattern as well. So that way there's consistency from tool to tool or workflow to workflow and how to execute something you find on Dockstore. And I'll come back to how we're planning on expanding the launch with functionality in the not too distant future in this talk. And so this is really just diving into the details of what's happening when you're executing a Dockstore tool or workflow. And what we've built into the Dockstore command line interface is, in addition to actually executing that tool based on the CWL or WDL that describes it, we did integrate file provisioning. So as I said earlier, you can pull files from S3 or write files back to S3. And that's incredibly convenient when you're working on virtual machines on the cloud and want to persist the data. Again, our goal here is not to write a tool that will let you execute this thousands and thousands of times. I think there are better systems for doing that, so we're looking at ways of integrating with those better systems for running these tools at scale. Okay, so once you've taken a look at the sort of basics of this tool, in this example I'm just clicking on the version tab, and this is one of the more important features of Dockstore. So by linking GitHub or Bitbucket with Docker Hub or Quay.io, what we're essentially doing here is we're linking the code and the versions of the code, the releases of that software, with the same sort of Docker images that are created from those releases of the code. And that's really, really important in the sciences. We want to be able to track back, you know, what version are we using, what version of the code was used to build that Docker image. And that's exactly what's happening here. You can see on the leftmost column, we're looking at the tag on Quay.io. And you can see, since Quay automatically builds our Docker images from releases on GitHub, you can see the tags are actually coordinated. So the GitHub references here are the releases of the software, and the tag is the corresponding Docker image that was built. And the reason that this is really important is we're showing a history. So as this particular tool or workflow evolves over time, we're actually preserving that history, and you can go back and use particular versions of the software in the future. Again, it all is being described and used by CWL or WDL in the same way. So a version that you ran a year and a half ago can be executed in the same way that a version that was just updated last night is. And that consistency is very important when you're trying to run tools from a previous study. Having access to these older versions is really important. Okay, another tab that I want to show you is, again, Dockstore is bringing in information from GitHub or Bitbucket. In this case, this is showing the Docker file, which is the recipe for how that Docker image is built. And this is actually really nice because you can, from a user's perspective, you can go in and without having to go to a separate site or track down the Docker file, you can actually view the Docker file here and understand exactly how this tool was set up and see essentially the instructions that were used to build that Docker image, which definitely helps with transparency. And finally, you can see the descriptor. In this case, it's a CWL descriptor. Again, this is just a YAML file that is both machine readable but also fairly easy to read as a human. And I think one of the features that we'll add in the future is something that gives a more graphical view of this to make it easier to understand the inputs and outputs. But you can see here the various inputs for this particular tool. And those inputs can be strings or ints or floats, as well as being files. And I think all the inputs shown here are simply files. Okay, so as far as developers go, what I showed you previously is essentially what the end user is seeing, what a bioinformaticist is going to be searching for on the site, and how they're going to find the technical details of how to run this tool and get information on it. But from the developer's perspective, Dockstore also provides a mechanism to publish work very easily. So for researchers that go ahead and put their tools or workflows in GitHub or Bitbucket and they build it with Quay, we're able to offer really tight integration with Dockstore. And so what you can see here is you can see my account, and you can see on the left-hand side, you can see all of my Quay organizations that I belong to. And the first one is my own personal one, and you can see the list of Docker images essentially that have been built on Quay. And when I click on one of those, I see all the details about that, very similar to what we were seeing before. But what I want to point out here is the Publish button at the top. You can choose to publish or unpublish valid Docker images that have a descriptor. They have to be valid in that way, but when they are valid, you can toggle the Publish or Unpublish button, and that basically makes it visible in Dockstore or takes it off of Dockstore. So essentially, if you follow our relatively simple SOPs, you can end up being in a situation where it's very easy to publish tools and workflows on Dockstore. All right, so I've talked a lot about where we're at with this project. Why would you use Dockstore? How would you use Dockstore? We definitely have interesting things coming up in the future. It's a project that's actively being worked on at UC Santa Cruz and OICR in Toronto. And what we're working on right now is a cool feature of workflow DAG view. So you can actually start looking at workflows that string together multiple tools on the site. And the other thing that I think is really important is testing the content that we have right now for PCOG, but also providing a generic mechanism by which a workflow or tool author can essentially define some test data that should go with their tool or workflow, some public test data that anyone can download and use. And that's really important because, if anyone can just put a tool on Dockstore but not provide sample inputs and sample outputs, it's a lot more difficult for someone to validate that it's actually working in their hands, or are they having problems because of their environment. So that's an important feature that we're going to push for. Another thing that I'm really excited about is we provided the simple Dockstore command line to execute things that you find on Dockstore sort of at a small scale. But I really want to see both open source platforms that people use, things like Galaxy or Consonance, and commercial platforms like 7bridges or DNA Stack. I really want to see those guys integrate and pull content from Dockstore. So we've been talking to multiple open source and commercial projects to support the concept of launching with their platform. And those discussions have been productive, and I'm hoping over 2017 we see some exciting development there. Again, Dockstore, we're intending this to be a registry of tools and workflows. We're not intending it to be a clone of Galaxy, an execution platform. we think that there are really great execution platforms on sites like Seven Bridges and the Galaxy project, and we basically want to support that. The other interesting feature that we're working on for the future is the concept of signed Dockers and sort of validated projects. And the idea behind that is we want to give a mechanism to people that are the authors of tools to indicate that, you know, while there might be 50 BWA tools available on the site, this one is actually from the author, let's say. And then finally, another thing that I'm really interested in is, again, I don't see the entire world putting their tools and workflows in just Dockstore. What I really want to do is I want to create a series of Dockstore-like repositories that we can cross-index with each other. And we're working with the folks at BioShadock to support the GA4GH API in their platform and essentially perform cross-site indexing. So BioShadock can show our content and we can show their content and link back to each other. And that's something that we had a Google Summer of Code student over the summer work on, and I'm hoping to roll that out into production pretty soon. Okay, so that gives you a really good idea of how Dockstore was made, why Dockstore was made, what was the motivation behind that. But as we were creating the project, we realized, again, this federated model made a lot of sense. And in order to do this federated model, we needed to establish a common API that multiple sites like Dockstore could implement. And what better sort of organization to do that than the Global Alliance, so GA4GH. And so what we ended up doing is working through the Container and Workflows task team to build an API for sharing Docker-based tools and workflows. And so this is the GA4GH tool registry API that I mentioned a little earlier. So at this point, we finalized the 1.0 schema and supported that in Dockstore. And other folks, David Mose at the Broad, are working on a reference implementation that's a super lightweight, super easy to set up implementation for people to kick the tires on if they want to set up their own Dockstore-like site. And again, the goal here is to not have all tools and workflows just flow to Dockstore, but to have a federated network of repositories that support sharing tools and workflows using the same API. And we're hoping to actually go ahead and publish this effort for with the partners that are implementing the standard in the near future. So the other thing that we want to do and are actively working on within the Containers and Workflows task team of the GA4GH is the flip side of Dockstore, which is the execution. And this is speaking to the desire to have various partner sites available through a launch with functionality. So in order to do that, we need API standards for how you execute tasks, individual tools in Docker, and how you execute full-on workflows. So the tool execution API standard from the GA4GH is moving forward. And again, that's an API for the execution of Docker containers in cloud environments. This can be a building block of workflow engines, so things like Toil or Cromwell can use this to execute on different cloud environments. And the core task here is we want to make it easier for workflow engine authors and people running Docker containers at scale to address multiple cloud environments without having to rewrite their cloud code for each cloud that they're working in, which is currently what people have to do. So the schema and reference implementation is being worked on by Kyle Elrod at OHSU, and a group of developers coalesced around this effort. And they've made quite a bit of progress already. It's very similar to if you've used the Google Cloud's JES, Job Execution Service. It's based on, inspired by that service. And we're in the phase right now where we really want to see feedback from potential users of the system, but also potential supporters of the system like Seven Bridges or DNA Stack or Pureverse, along with open source projects like Galaxy. It's really important that we get that feedback and we get that support from those communities. and hopefully we can end up using this as a sort of execution mechanism for other projects in the future. So right now we do have a Go-based reference server. It's working on a shared file system. It's considered an alpha, and right now Kyle has a sort of proof of concept that links CWL, the CWL execution engine to the task API. What's happening next is supporting OpenStack instead of just sort of local execution or shared file system execution, and pass the CWL conformance test to make sure it's actually passing the 1.0. And finally, working on Cromwell, which is a very popular WDL execution, workflow execution system, to use this plugin, along with adding support for authentication. And then the final sort of API that the Containers and Workflows task team with GA4GH are working on, that's again applicable to things like Dockstore, is something that's very similar to the task execution API, but it's focused on whole workflows defined in WDL or CWL, and perhaps even in the future Toil Python-based workflows. And I'll talk about Toil in just a moment. So like the task execution API, this is an API for submitting workflows to cloud-based environments. The schema and reference implementation are being worked on by Peter, and the work right now is to essentially harmonize this API with the task execution API, since there's a lot in common between the two, like status messages should be harmonized, the mechanism by which you get standard error and standard out should be harmonized. And again, this higher level API could be built on top of the task API, and we're hoping other platforms will support it, things like Toil, for example. So what's our sort of ultimate vision, and where are we going with this as far as the GA4GH and Dockstore goes? So Dockstore is production, it's 1.0. We're really hoping to work with people in the community, do outreach, do additional training seminars, and use it both ourselves, but also as a community to share tools and workflows in a highly standardized way. But once we have those tools and workflows ready to share, the other sort of goal for this group is to provide both workflow and task level execution in cloud environments that hides the differences between clouds. And I think early 2017 we're going to have the schema completed for this and reference implementations to follow. So this is really an exciting time to be part of the GA4GH, the Containers and Workflows working group task team, but also just to be part of the community when we finally have really good tools for moving tools and workflows around to, from environment to environment. And I think that's becoming increasingly obvious that this is the sort of model that we need to use going forward. This PCOG model of moving the algorithms to the data is the right thing to do for us in the future as our data sets grow larger and larger. All right, so I think Benedict may have joined us, and he might want to walk through the Toil slides. Benedict, are you online with us?
I am online. Can you hear me?
Yes, I can.
Okay. Yeah, I'm happy to. Please jump in and guide me, because I only joined about 5 minutes ago due to traveling.
Okay. Sure. So I'm going to hand it off to you, but I'll definitely interject as we go.
Okay. And
so you'll just let me know as to when you would like me to change the slides, and I'll move them forward for you. Okay.
Okay. Thank you. So so Toil is essentially a method for executing the workflows. So it's great that we now have CWL, and I don't know if you mentioned WDL, Brian, the workflow description language from the Broad, but both of these standards decouple the definition of the workflow with containers and with Docker from the actual execution of the workflow. And repositories like Dockstore and the GA4GH execution APIs give us flexibility to both share those things and deploy them at different locations. It's really important that we have multiple execution options. It's clear that in the genomics space and the biomedicine space in general, we need healthy competition. we now have an emergence of industry providers like 7bridges and Curaverse who are supporting standards like Common Workflow Language, and there are lots of academic groups and academic interest across the sciences in supporting particularly Common Workflow Language, which is just hitting 1.0. Now, for our purposes, we wanted to create an execution engine that fitted our needs, and I'll get to those in a minute. And so we developed Toil, which is this fully open source platform that you can go and look up at that particular GitHub URL that I'm pointing to. We started it about 18 months ago. So far we've had, just to sort of highlight the open source nature of the project, 26 contributors, mostly from UCSC, but we have had members from 11 different institutions commit a significant amount of code, particularly on the CWL side. We've had more than 1,800 commits, and we're now at a point where we're getting about 100 unique users checking out and using Toil every couple of weeks, is what I can see from GitHub, which is pretty good. So next slide. Hey Brian, can you move to the next slide? Sorry.
Yeah, did it not move?
It didn't move for me. Oh, yeah, there we go.
I guess there's a significant lag.
Yeah, all right. Okay, Toil. So we currently support Common Workflow Language. We actually haven't hit 1.0, but I think we will do soon. That's a priority for us. And on a branch, we have nascent WDL support, and plan on developing that as resources are available, so that we have a system that supports CWL, WDL, and an internal Python API that we have, essentially an SDK that allows you to build workflows, and that provides a kind of Turing powerful language as a backing for building really complex workflows, that some of which you can't currently develop in CWL and WDL, and it's kind of essentially gives you a superset of features that allow you to do things like deploying databases and so forth. So Toil is deployable in a single command, pip install Toil. It's pretty easy. Anybody who wants to do this right now can check it out and develop workflows locally on their laptop. So if you go read the docs, read the tutorial on developing workflows, you'll see that pretty simply for a sort of hello world demo, you can get going inside of a few lines of code. The beauty of Toil, though, is that once you've got that workflow developed and debugged on your laptop, you can then take it and relatively easily, we'll get to that in a minute, you can run it across a variety of different platforms. So clouds such as Amazon, Azure, Google, so the commercial clouds, also nascent OpenStack support, and support for a bunch of different batch systems within HPC environments like Slurm and Grid Engine, etc. An important feature of Toil is that it's entirely resumable after failure. What that means is that this is a distributed computing engine. It's designed for parallel execution. We'll get to that in a second. And if the compute that you're using fails, you're always able to go back to the last checkpointed state, and that checkpointing is extremely fine-grained. You can lose any combination of nodes or even the master process that's running those nodes, and the whole thing is you can pick it back up, providing the essentially the database that's tracking the state has not been corrupted. It's simple. It's built entirely in Python, and as I mentioned, there is a nice SDK in Python that uses essentially it's a sort of functional programming design, but we don't have time to get into that. Okay, so next slide. I'm sure it will update in a second. Ah, there we go. Okay, so just to kind of show you that this is not vaporware and that this can run at scale, we had need to recompute a number of data sets I'll get to in a second, all RNAseq data sets. So we developed a Toil RNAseq pipeline that you can see here on the left, and it's fairly straightforward. Essentially, there's some download steps where the data is being pulled off from the repository where it resides. So it could be on S3 or it could be on a local file system. There is then a step where a bunch of kind of munging processing happens, and then a series of algorithms are run. So actually, two parallel algorithms. In one case, we're doing gene level expression where we do the traditional mapping of the RNA-seq reads, and then expression quantification with RSIM. And then in parallel, we use Callisto, which is an alternative algorithm that uses colored Deborian graphs and doesn't have an alignment step to do transcript level expression. Then there's a consolidation process, and a bunch of outputs are uploaded and to various places that you specify. And just on the right-hand side, you can see there's a gene-level concordance plot between this pipeline that we developed, denoted CGL here just for our lab, and the TCGA best practice, just showing a very high level of concordance between the two. Next slide. So while it's moving, okay, so we had need to apply this to a large batch of samples. We are essentially, within the context of a pediatric cancer project, were sequencing and profiling a series of pediatric cancer patients, and wanted to compare those patients to, the massive library of available, available to researchers data. But unfortunately, all of those data sets were computed with different pipelines that introduced different computational batch effects. And so to get around that, we realized that the simplest and most direct approach was to just recompute all the data. I think this is an increasingly common theme that would allow us to do cross-comparison between these rich and interesting data sets. So all told, that was 20,000 RNA-seq samples. It was essentially the entirety of all the samples in TCGA, that's about 9,000, all of GTEx, which is about 8,000, and then a smaller number adding up to about 20,000 from Target, PNOC, and iSpy2, all clinical sequencing pipelines. Set that, so the aim here was to remove computational batch effects and to essentially create this sort of normalized prior for the comparison of these pediatric samples. So great, next slide. So we did this as a demo for Toil. We're using the output. The output is all publicly available, but just to show you how this was scalable on a commercial cloud environment. So we ran essentially, apart from the iSpy2 data, we ran the complete data set using Amazon. And we were able to, so on the left-hand side, there's a sort of cost and scaling projection. So on the x-axis, you see the number of cores, and on the y-axis, you've got the cost. The red line is the cost of using the existing TCGA pipeline, which was prohibitively expensive. Essentially, it would have cost us around about $1 million to do the complete recompute with the original TCGA best practice, which really motivates why we had to develop something more efficient. When we'd finished, and we used a series of optimizations that I don't think I'll have time to talk about, when we'd finished using the spot market, this market in which you can bid for compute at lower cost than if you were just reserving the instances, we were able to get the cost down of our pipeline down to about $1.30, which meant all told the whole pipeline to recompute all the data was about $26,000, which is obviously an awful lot less than the projected $1 million. To see how quickly we did that, on the right you can see the whole thing. This is a sort of a timeline of the compute over 4 days. So the entire compute was done in 4 days. You can see on the top right panel the number of cores that were active over time. Because we were using this computational bid, this market for compute, we were trying to bid fairly aggressively to keep the price down. Not all the compute was available to us at all times, but you can see that at peak times we were using about 32,000 cores, which is fairly impressive. Because we were jumping between nodes, because nodes are being switched off, it all goes back to that resumability, that ability to transfer compute and not lose progress. All told, we swapped between about 100,000 cores over the course of the compute, demonstrating that Toil can be used at pretty massive scale to do impressive recomputes. Next slide. Okay, so I'll jump past this one. So next slide. This is just showing that we were able to mine this data for a bunch of interesting associations, combining the TCGA, so it's a cancer genome atlas, with the GTEx, which is this library of normal quote-unquote normal tissue expression to demonstrate interesting existing results, and it allowed us to find a lot of other things that are now in progress. Again, so we'll also skip this slide, so next slide, but this is just pointing out that there's a whole lot of optimizations under the hood, and that's the great thing about decoupling execution from definition, is that it allows people to innovate on the optimization side and deliver different, essentially compete on being able to produce the lowest cost possible compute. One of the features of Toil is its ability to spin up within the context of a workflow a larger cluster of sort of codependent or sort of service tasks. So here we've implemented the ability to spin up completely containerized Spark clusters, so that within the context of an existing workflow you can bring up a Spark cluster, which in and of itself is a distributed compute environment. Bring it up, interact with it, process with it, and then bring it back down, and have it all work in a containerized and portable fashion, which is kind of mind-blowing. So next slide. And that's usable now if you go, and you can see it's on the latest release. Okay, so things that are kind of coming in Toil. So we're currently working on this concept of auto-scaling. So currently, if you're using it on Amazon, there is a need to essentially provision the instances that you're running on, which makes it a little bit more complicated than we would like for people to be able to kind of use this at scale. Once auto-scaling is in, we are sort of at the point of demoing it now, then you will literally start from a single image, and from that image hit go with your credentials, and then Toil will handle all the rest. It will spin up the nodes it needs, and then it will spin down the nodes it needs over time, which is a pretty difficult engineering task, but will essentially allow us to get to this point where it is you're going from a containerization that runs on a single node to containerization that can containerize itself over a large number of nodes, at the scale of thousands of cores. We're producing a lot of pipelines in Toil. We are trying to work with the community to get to allow Toil to be a first-class. I think it is right now probably the easiest option for running CWL, the easiest open source option for running CWL pipelines. As I say, we are expanding this. As we get this auto-scaling support in, we will expand the number of environments that we support in which auto-scaling will work. All to do with back-end APIs that kind of minimize the amount of difference in terms of implementation that we need as we move from, say, Amazon to, say, Microsoft or to Google. I think that's it.
Yeah, so I'll just hop back in here, Benedict, and kind of take a step back a little bit and try and put together a picture of how does Dockstore and Toil and the GA4GH really fit together. And take this slide with a grain of salt. I mean, this is a proposal of what we want to see and how we see things fitting together. It's not a commitment by Curaverse or Seven Bridges or Synapse to support this. This is just kind of a concept of how we might all work together going forward in the future. And the idea here being that using this GA4GH API for tool registry, we could have many registries like Dockstore. This is what we want to see have happen. We're already working with the BioStock folks, and groups like Synapse and other groups are creating Docker registries as well, so we're hoping that they join us in this network. So in this sort of vision, we have multiple places where we can pull workflows in CWL or WDL or maybe even Toil native workflows or other workflows in the future along with tools in a standardized way. And those workflows can flow, as Benedict mentioned, can flow to multiple execution engines. So to have multiple places where we can execute it based on cloud or based on particular facets of the execution platform. For example, Toil being a very efficient location. Other platforms may be providing more of a GUI, like FireCloud, for example, or Seven Bridges. So using that workflow execution API, we can really see a standard way for all of these sites to work in the same way and receive requests in the same way, which would be extremely powerful for us in the community that want to send our work to potentially multiple vendors, something like what we did for PCOG, where we needed to send the work to multiple sites. And from this, these workflow sort of execution engines, and on the GA4GH side, we really want to provide this task execution API that would make it possible to address Amazon, Azure, Google, all in the same way for executing individual steps in a workflow, but also potentially even HPC environments. So that lower level API gives a lot of flexibility for things like Toil to interact with multiple cloud environments. And finally, that really allows us to start driving decisions about where compute is done, not based on where you support the particular cloud API, but more driven by things like cost and also where the data is located. And that's really, I think, a driving decision moving forward in the future. So this, from a high level, is really, what we're headed to and what we're hoping that these standards will help us achieve, with Dockstore and Toil being good examples of platforms that will work in this ecosystem. And with that, I just, on my side, I want to acknowledge the Dockstore project. The Container and Workflows task team with the GA4GH has really been helping to drive that standard forward for not only the tool registry, but also the task and workflow API. And in particular, on the Dockstore side, I want to thank Dennis, who's working at OICR, and we're collaborating between OICR and Santa Cruz on the Dockstore development. Kyle, who's working on the task API, Peter, who's working on the workflow API and is also the co-leader of this task team, and Jeff, who's the co-leader of the task team as well. And I just wanted to acknowledge the work of the Toil developers as well. And Benedict, you might want to jump in here. If the slide is actually transitioned, it sounds like there's a 30-second delay. But of course, Benedict, Toil was created because of Benedict's hard work and vision. So I want to acknowledge, the leadership that he's provided there, along with David Hausler. And Hannes is our software architect and has done an amazing job on making Toil a stable and robust and community-driven and open project, along with a whole lot of other folks, ranging from developers to actual workflow developers and people creating content that run on top of the Toil system. If anyone's interested, I did leave my email address at the end of the slide, and I'm happy to answer further questions now and over email. I'm sure Benedict is the same. We can answer some questions in the time that's remaining. And Benedict, was there anything else you want to say as far as Toil acknowledgements? Am I?
No, you're doing a great job. Sorry, I'm being interrupted. You're doing an absolutely great job, Brian. And yeah, no, it's very much a team effort on this side. I think did you talk a little bit about sort of near future tasks? I saw the vision document. I think that we are going to increasingly build out this network, and I think we're going to continue to demonstrate how we can make biomedical computation portable and scalable, and that really does require quite a team effort.
Right, exactly. All right, with that, any questions from the audience? Okay, if not, thank you very much, everyone, for attending. And again, I'm happy to answer further questions. Please feel free to reach out to me at my UC Santa Cruz address at the bottom of the screen.
Thank you, Brian, and thanks, Benedict, for putting that great presentation together. So we've recorded this presentation, and we'll host it on YouTube and on the BGK CCC website. If you have any colleagues who you think would be interested who weren't able to attend today.